A cylindrical glass vase is filled with 20 spherical Christmas decorations as shown below. Not all of the decorations are visible in the diagram. All the decorations have a diameter of 1/3 of the internal diameter of the vase. So a bit later on we're going to define that to be R. So for the cylinder, the radius is R, and for each of the spheres it's going to be R divided by 3, or 1/3 R. They are all completely contained within the vase. For design purposes, the sum of the internal diameter of the base and the vase's internal height is to be 42 centimeters. So the diameter is 2R, and if we call the height H, so we'll call the height of this H, that sum is going to be 42. Now if we look at this formula for the volume, it doesn't contain H. So that suggests to me here that I should write H is equal to 42 minus 2R, and that we're going to use that somewhere. So let's think about the volume. And this is for the unused space in the vase. So we're going to start off with the volume of the vase, which is going to be pi r squared h. That's the volume for a cylinder. And then we're going to take away 20 lots of the spheres. So that's 4/3 pi r cubed. So this is going to be pi r squared, 42 minus 2r, take away 80 over 3 pi r cubed. Now it's just struck me here that I've made a slight mistake, because for the sphere we know the radius is rr over 3. So this one is going to be r cubed over 27. Okay, so we straighten that out. So I have got 42 pi r squared, take away 2 pi r cubed, take away 80 pi r cubed over 81. So that's 42 pi r squared. Now 2 pi r cubed would be 162 over 81 pi r cubed. So that's going to be 162 over 81 pi r cubed. Take away 80 over 81 pi r cubed, which gives me 42 pi r squared. Take away 242 over 81 pi r cubed. Now if we take 2 pi out of there and open a bracket, we've then got 21 r squared. Take away 121 over 81 r cubed as required. We can see that just here. Use calculus to determine the dimensions of the vase that will maximize the unused space in it. Give answers rounded to the nearest millimeter. So I've just brought over the expression that we need for the volume, what do we want? We want the dimensions of the vase that will maximize the unused space in it. So we're going to need dv dr is equal to 0. Now for 4 marks, I suggest we show some working here, especially since this is not difficult to differentiate. So dv dr is going to be 2 pi 42r take away 3 times 121 over 81 r squared. And of course we can do some cancelling there. So that's going to be 2 pi 42r take away 121 over 27 r squared. And if that's going to be 0, that means that 42r take away 121 over 27 r squared is equal to 0. And so we can take out an r here and have 42 take away 121 over 27r equals 0, which means r is 0, and that's clearly not going to be the one we want. Or that 121 over 27r equals 42, and therefore r is going to be 42 times 27 divided by 121, which is going to be 9.4 centimeters. That is to the nearest millimeter, remember. Now we also need h, and h was equal to 42 minus 2r. So that is going to be 42 take away 2 times my last answer, which is 23.3 centimeters. So the final part of the question says, can more than 20 of the spherical decorations fit inside the vase in part B? Okay, so if we think about the vase, which is pi r squared h, the volume of that is going to be pi times r squared times h, and that is 6417. And if we think about the spheres, there's 20 of those, and it's going to be 4/3 times pi times r over 3 cubed. So that's going to be 20 times 4/3 times pi times, so that was the r, divided by 3 cubed. And that is 2554 cubic centimeters. So there's clearly lots of space for additional spheres. As we can see here, the spheres actually take up less than half the volume. But it depends on packing. It could well be that we actually can't get one in, even though there's plenty of volume for it.